Hey folks, Sega Sonic fan here. Today I have another weird hack for y'all. I don't know if a lot of people are going to find use for this, like most of my hacks, but I had fun learning about it either way. But if you do find this interesting, please post a comment. I make these videos for free, and it's always cool to hear if people use any of this weird stuff that I'm doing. This right here is a little mini 4-port KVM switch that I recently just hacked. And by recently, I mean just now, tonight. I've been wanting to hack it for a while. And it comes with this super crazy cable. So a little backstory on this, and the reason why I was doing this in the first place. KVM switches, for those that don't know, are used for switching a monitor, and in this case, old school PS2 style keyboard and mouse. No, that's not Sony PS2. That's a different. This is an actual standard of serial communication from back in the day. And so this was a way to, these are 4 inputs and 1 output, and you can switch between them with the push of buttons, which I have removed because I'm adding an extension. I'm going to add a breakout board so I don't have to reach into my TV stand every time I want to change it. Hell, if I want to get really fancy, I could add remote control. But yeah, so this guy's pretty sweet. I use it for my RGB modded video game consoles. If you follow my channel at all, you'll see that I hack a lot of CRTs for RGB, and I'm a big fan of old school 15 kilohertz interlaced RGB for all my classic game systems. It's the only way to go, in my opinion. Screw all that emulated crap that's out there, like the AT games and the Retron 5 and all that can go to hell. It's all about the classic, actual hardware consoles running pure video output, RGB. So I use this thing, and I've been a big fan of it, but there's a couple serious problems. One is that it locks up randomly. It'll just completely, none of the buttons will work, and it will completely lock up on whatever channel you have it set. Usually this is when I plug in a standard VGA cable, which made no sense to me, because this has VGA input. Why would it lock up? I have custom cables I'm using for my game systems, but I'm using the same pinout that a home PC uses. So why would it do that? I was very confused about that. The other is that this LED annoyingly would just always blink. So when I had a signal running through it, if you look down here, it beeps, and then, well, got the light on it, so. Well, right now it's not actually going to blink because I've figured out a fix for it, which is this wire jumper right here. But if I remove this wire, let's go ahead and just see if I can actually pull it off. It starts blinking, and you'll see that. So with this wire removed, it just blinks all the frickin' time, and it's so annoying. And every time I change consoles, there's just this green blinking light under my TV that's really distracting. And yes, it runs all night because I don't unplug this thing, and it doesn't have an on and off switch. So unless I go down to the surge protector and, you know, switch that off, which is way behind the TV, this is blinking in my living room 24/7. So that got a little bit annoying. That and the lockup got a little bit annoying. And I had no idea why for the longest time until I found one of these boxed. By the way, this is the AirLink 101 4-port KVM switch slim. I like this one a lot because it's very tiny. So when I found a boxed one, I pulled out these cables just the other day, and it explained everything. So this is not a standard VGA input at all. They have their own custom cables that you're supposed to use with this thing, and it looks exactly like a standard VGA D-Sub 15 HD, but there's 2 extra wires you know, coming out of this cable, which are the mouse and keyboard PS2 serial data. And so what this thing does is it actually detects, turns out it only needs 5 volts to detect, which is why that LED is blinking. The LED is blinking because it's like, you don't have anything plugged in, what's going on? And as soon as you give it 5 volts, it stops there because it's like, oh, you got something plugged in here. This 74HC4052 is a 4-to-1 multiplexer that only swaps the 5 volts coming in on pin 7. That part is standard. Pin 7 usually is 5 volts on VGA connectors. So that part's fine. I wasn't using 5 volts output for my consoles. I don't need to. So that's why I got the blinking light. Okay, that's an easy fix. The bigger fix is the lockup. Or the bigger issue was the lockup. And you'll see here in my notes, I had to kind of trace things out and figure out what the hell was going on here. And so first, I don't really know much about PS2 serial data, so I had to learn a little bit about it. And the first is, here's your green pinout, here's your purple. And there's really only 2 pins that are used. There's a data pin and a clock pin. There's a ground, a plus 5 volts, and 2 reserved pins. I love how they always do that, which is really just, they're not used for anything for standard equipment. And so there's 2 pins for the green that are necessary. 5 volts and ground, we already know that's going in regardless. That's VGA standard. What's different? There's 2 pins for the green, 2 pins for the purple. Where do those go, and why would they be causing a lockup? Well, so with further tracing this thing out, I found that those pins, and I actually drew it here in the most crude chicken handwriting style ever, chicken scratch, that pin 5, 4, and 7, I'm sorry, not 7, 6 and 11. 5, 4, 6, and 11 go to these pins. Now, why did they choose 5, 4, 6, and 11? They're not really used in most VGA applications. However, VGA cables have some of these shorted to ground. 5 is usually used as a ground. And so when those short to ground, it confuses the hell out of this chip because it's looking for clock and serial data information, and it's like, what are you doing? So to make this thing work with standard VGA cables, I have to cut those connections. I have to cut those wires. Turns out the path they follow, by the way, for anyone interested, is they go through, here's 4 right here. This is a good one. This is where I found it, is these 4 vias right here go through 4 10K pull-up resistors, and then they go to this chip right here labeled U7, or get my camera over there. So that chip right there, U7, and one all the way over here, which is U10. These chips, for those that don't know or are interested, are PI5C3252Q switches or multiplexers. They're pretty cool. They're actually 5 ohms on resistance, which makes them pretty ideal for what they're doing. I don't know about the quality for analog signals, but I assume it's good enough. Seems good enough on my monitor. A little bit of interference, but I'm going to chalk that up to other issues like this one that I'm fixing right now. So it goes to those 2 switches, those 2 multiplexers, and then those multiplexers have 4 inputs, right? Because you have 4 inputs here, and 2 outputs. So actually 8 inputs total. And those 2 outputs go on to this microcontroller, this programmed microcontroller, which is MDT2020. And that handles, like the button press that switches everything. It's basically a 7474 inside there. Handles the LED blinking that you see there, which is a 555 timer type deal. It's all integrated in here anyway. So what you have to do is cut those 4 pins, and I traced it out here in my awesome, really crude diagram here. And it's the top 3 pins on the microcontroller and the one bottom pin. And if I counted right, let's hope that I did, it's 14, 15, 16, and 17 are those 4 pins. And this is the chip upside down, so it's going to be that pin, that pin, that pin, and that pin. I went ahead and cut those, and then because I cut them in the wrong spot, I had to add those pull-up resistors again, which is why, sorry, my camera's not picking this up so great, but that's why I added this red wire here. So there's 10K resistors to 5 volts on each one of those. So there's 4 10K resistors going to 5 volts. And that's just because the signals from the microcontroller might get confused if it doesn't have those. They're there for a reason, when nothing's plugged in. So I figure put those back, probably to keep it from oscillating. And that's it. That's it. So, got this thing to stop blinking. Figured out, by the way, for those that want to make this stop blinking, the easiest way is pin 3 or pin 21 on the microcontroller. Pin 21 on the microcontroller goes to pin 3 on the 744052, and you connect that to ground, and the LEDs will stop blinking on you. So again, the purpose of this hack is that you can plug VGA, standard VGA, into this after doing this hack, without using these really old style PS2 connectors, because nobody uses those anymore, or at least I don't. Not a lot of people do. So this is a great little mini KVM switch. It's the smallest one I know of, actually. I've not seen one smaller than this. I'm sure there's probably one somewhere, but I really like how cute and tiny this thing is. It runs off almost any voltage because it's got a 7805, taking it down to 5 volts. And so it's really versatile. They're super cheap. I mean, I found this one for free. People are just throwing them out left and right. You know, it's got 4 LEDs, and it's a nice little piece of gear for your gaming equipment, or if you want to use it as a standalone KVM and not have to deal with the proprietary cable mess because you're not using PS2, you're fine. One last thing I'll say in closing is that these switches, let me go ahead and give you an example. I'm going to go ahead and use these tweezers to short the button press, and you'll get a beep there. Now, when I go back here, depending on how finicky it is, when I go back to, you'll see the first LED is off now because it's on channel 4. You heard that double beep? That means it's kind of angry, and it's not registering the button press. The reason for that is, my belief is that this thing really needs a Schmidt trigger. It really needs something, a debouncing circuit, to really make it handle these button presses. The buttons that are in there are really long shaft tactile push buttons that are like super prone to debouncing issues because the long shaft makes it angle improperly when you're pressing it, and that causes problems with the disc over time. All the useful things you learn about over the years opening up little switches and crap. They don't teach that at MIT. And yeah, you have to replace those probably after some time, or, you know, do a breakout board like I'm doing. I think that'll be the ultimate solution. And, it, you know, it could be fine, actually. This is kind of nitpicky stuff. But just, you know, if I'm upgrading this thing fully and hacking it, I might as well finish the job. And I might actually put in a 74HC14 Schmidt trigger with some debouncing stuff, just to make those button presses really clean and make this thing beep at me less. Stop beeping at me! And yeah, that's pretty much it for this guy. So hope somebody found this video interesting. Again, please leave a comment if you find any of these videos interesting. I do read them. And it's always cool to get rooted on for this weird home hacking work that I'm doing. It gives me more inspiration to actually go through the process and get my lazy butt up and spend, you know, an hour uploading this to YouTube, which I don't like, but I want to share with you people the stuff that I do. Thanks for watching. Happy RGB gaming for those that are doing that. And hopefully I'll see your comments sometime. This is Sega Sonic Fan, signing out.